Right, so let's have a look at App 2. Hopefully by now you've had a chance to have a look at the wiki page for App 2, which details the requirements, also suggests some testing, shows the design, and if you were to scroll down, you'd also see some extensions to which you can achieve more marks should you wish to attempt them. So I think what we'll do is we'll focus on the initial requirements, the basic requirements. Let's get that set as the foundation, and then in the second half of the video we'll take a look at how we might start some of those extensions. So hopefully you've had a chance to read the initial requirements, and if we focus on the first section, which specifies 3 tickets which we need to create in this application. And you see here we're given some sample data, so we're given the destinations and we're given the cost of each ticket. And if you have a look at the first feature, hopefully we can get a feel for how that might be translated into code. So as you can see, we've got 3 tickets which all have a destination, a cost, and the date at which they were purchased. That's the intention of this application. So if we translate that into code and how we might represent that in code, hopefully we can recognize that as we have a group of related items, tickets, we could represent that as having a ticket class through which we then create 3 ticket objects, one to represent each ticket and the sample data. So hopefully the giveaway here is each ticket, which means that we can have 3 ticket objects of a ticket class, and that ticket class could specify these as fields. These are characteristics, destination, cost, and date purchase of each ticket. So therefore we have fields for destination, cost, date purchased of a ticket class, of which we can then have 3 objects. Right, so hopefully you can infer that from reading the first requirement. So let's have a look at the ticket class here. You'll have to create this, it should be said. I've already done this just to save a little bit of time here. And if you want to see how those translate directly, here we go. Destination, I recommend using a string, simply because that's going to be letters predominantly for Aylesbury, Amersham, and High Wycombe. Cost could be modelled as a double, it should be said, which has a decimal point in it. If you haven't used doubles yet, perhaps better to stick with integers and represent the price in terms of total number of pence rather than say 2.20 or 3.30. You know, using pence would be fine. That's not a problem. And for the date, perhaps when you're starting out, you could represent it as a string. In the second half of the video, we'll take a look at how that could be represented using a date class, which has specific formatting for dates and times. But perhaps just to start with, let's get it working with a string for now. Then we can go back and change it later. So there you go. They're the fields for this ticket class. And remember what we did last time in App 2, we actually set the values for those fields in the constructor of the class. Remember in the course class, we actually passed in the code number and the name of the course, the title of the course. We passed those into the constructor via setting up some parameters. Remember, we had duplicates of the field variables in here. We actually created new variables that are local to the method, the constructor, which temporarily store data that you pass to that constructor. Remember, the constructor is called when you actually create the object of a class. We're going to follow a very similar format here for the tickets, where we pass the information to the constructor for each object. So if it's Aylesbury, we'd want to pass in the string Aylesbury there, and the cost, and the date, whether that's string, or if you choose to later do the dates class, you can set it there without having to pass it in. But we pass it into these parameters, and then we set them, we actually assign to the class variables, the fields of the class for that particular object. And remember that the this keyword is used to refer to those fields. Because otherwise we'd have to specify whether it's the Aylesbury object or the Amersham object or the High Wycombe object. This can actually act as a placeholder for whatever particular object that we call the constructor for. All right, so it'll automatically take on the memory address of either the Aylesbury object, the Amersham object, or the High Wycombe object, depending upon which object we actually call it on. All right, so it's a very useful way of cutting down the amount of code you have to write, and also useful to tell which variable we're referring to. Yeah, because this dot destination refers to the field variable, whereas destination without this just refers to the parameter. Right, so that's what we're doing there. We're just assigning those details to the fields, and you'll see this again and again and again for all of the constructors. It's a very typical format, very typical pattern, so you'll get used to that. So let's move on to the other methods that we've created here. And the next method is the print method, which refers to the second feature, which is to print a list of available tickets. It makes sense, like we did for the student class and also for the course class in the previous app 1, to also do something similar here for the tickets class. Here where we can actually just call the print method to print out the values that are stored in the fields for that particular object. Right, so we've just called the system.outputPrintLine method to print out the values for those fields for that particular object. And this is going to be a useful way to later on, when we get to the ticket machine, where we actually want to display the list of available tickets for which the customer could purchase. Right, so we just then call the print method for each object. Yeah, really simple to actually print out what destinations are available. All right, so that's what I recommend doing as a simple way of printing that list out. So let's have a look here. Oh, and finally, we've just got getters for the particular fields of the class. It should be said you don't have to do this, but if you want to add these in, the getters and setters, these should have been covered in the chapter 2. So hopefully you'll have a little bit of familiarity with them. The accessor and mutator methods, that's sometimes what they're also known by. But this is useful if, say, when we get on to printing out the ticket later, it'll allow you to customize the formatting. So, let's go back here. Let's go to here. And you'll see in this particular case for the print method, I'm actually choosing to print them on the field data on the same line. You'll see this. Even though here it's spread across 3 lines, the only reason for doing this is just for the window. It says it's having to scroll along. But when you'll see later, it actually prints this data out on the same line. But should we want to print them out on different lines, we could actually just then call the getters for that particular piece of data we want to print. But easier to have a look at a visual example of this, so we'll come back to that. But just to cover what's left in the ticket class, I think that's it there. So we've had a look at the first 2 features. Let's now go to the ticket machine class, which is given to you to fill in the other half of this. So if we go back, have a look at yes, because we need to actually create the tickets. So we've got the ticket class, but then we actually have to instantiate the objects. So let's have a look at how we do that in the ticket machine. And again, later on, there's an extension where you could actually set up constants for the tickets, because they have data which can be declared once and never changes later. So you could represent them as constants, but just to stick with what we're familiar with, for now, let's just set them up as dynamic variables. And here, we're going to do something very similar again to what we did in app 1. So we're following a similar pattern where we create an object of each of the ticket class in the ticket machine, to which we then create the data for it here, as you can see. I could actually have this second half, I could actually put that up there if I wanted to, but I'm just for neatness, I'm putting it in the constructor because that's where all the other data is going to be initialized. All right, and there's actually a reason why we're creating the objects in the ticket machine as opposed to creating them on the object bench. I mean, it should be said you could do that. You could right click and create the tickets so they appear down here when you run the program. But just to fit with the scenario, it's better that the ticket machine creates them rather than the user, because the user shouldn't be concerned about creating the ticket objects to then purchase. Really, it just wants to see those ticket objects pre-made so that it can then select one of them. So that's the reason why we recommend creating the objects in the code rather than creating them at runtime when you run the program. All right, so that's what we recommend there for that. Let's just talk about this. And regarding the tickets as well, the original version of the ticket machine is set up to work with one ticket. So that's why you'll see a price field declared in the ticket machine, because that's referring to the price of a ticket, assuming there's only one. But as we've taken this a little bit further in this assessment exercise, where we've got 3 tickets and therefore meriting a ticket class itself, we recommend modifying this slightly so that you can then get the ticket price from the ticket class itself. And if you remember what I was saying earlier about the getters, that might be a useful way of getting that later. Hence why I've got a get cost method. Yeah, and note actually it's called cost in the ticket class, but as per the requirements. But here it's represented as price, but same thing. Okay, just different name. All right, so the thing about this, though, I've commented out here because I've also commented out in all the other places where price is referred to. If you've read the code for the ticket machine, you would have seen later under the printTicket method that price is also used in a conditional statement, to check that you can actually buy the ticket. You've got the right amount of money. It's got a little check there. Which again later we'll have to modify. You'll see here I'm referring to the get cost method rather than price of. So the problem, what I was saying earlier, if you actually comment out or choose to delete some of the code relating to price, you may have some of the red underlines popping up because there'll be other references to price. All right, so if you do get that, don't worry. It's just because there are lots of other references to price within the ticket machine. So perhaps for now, you could leave it as it is, and we'll address it later. All right, I've only commented out here because I don't need it, but best to address that later. Best to leave it there for now and then come back to it later. All right, so let's move on then. We've talked about creating the tickets. Yeah, so I've created the Aylesbury ticket object here, but of course you'd have to go on and define the others for Amersham and High Wycombe. So again, similar format, just create the objects alongside the Aylesbury one. And then if we come back to the second feature here, where you want to print the list of available tickets, we've got the print method in the ticket class, as we saw earlier, which will just print out the details for the ticket object. We then just want to call that print method in the ticket machine. So I've created a method called display destinations, from which I've then called the print method on the Aylesbury object. You would then do the same for the Amersham and High Wycombe object. Okay, and actually just to show you a visual example of this, just to might help make things a bit clearer. Let's just show you this. Okay, so let's just create a ticket machine. I'm going to call it Chiltern Railways. Oh, just for now, but of course it could be a ticket, depending on where you see this ticket machine. It could be a ticket machine at a particular ticket office at a station, or it could be somewhere else. But I'm just going to call it Chiltern Railways for now. And let's just show you what I mean by displaying the destinations. So here we go. Here's the output here. And you'll see this is the calling the print method of the ticket class for the Aylesbury object. You'll just see here that this is the only current destination that I could choose from, but it's all printed on one line. So you'll see that these were written as strings, and this is the data from the fields for that particular object. Right, so there you go. When you want to print the list of available tickets, which of course is to follow what the user would typically be presented with. You know, if you go to a railway station and you go to one of the ticket machines, you know, the first thing you would typically do is select a ticket from a list of available destinations. So that's what this is trying to represent. Right, so let's move on from there. So yeah, of course, we want to select one. So we've printed them out first of all, and the next thing to do here under number 3, the third feature, is to select the tickets. Right, so let's jump back into the code here, and again, there are multiple ways you could do this. So if you're comfortable with user input and using if statements, in theory you could ask them to type in which ticket they want to choose, but because input is a little bit more of an involved process than in Java, we actually cover that a little bit later in the module that's coming up in App 5. But for now, let's just focus on something that's really easy to do, and an easy way to select a ticket would be to just create a method which represents the selection of a ticket. So here you'll see I've just got a method which can be called to represent the selection of the Aylesbury ticket. All right, and what this does is this actually copies the Aylesbury object, which I created earlier, into another ticket object called selectTicket. I didn't cover this earlier, but this is the other ticket object, which I've got here. And the reason for doing this is that it makes it a lot easier when I come to then print out the chosen ticket later. Again, a little bit like, it acts a little bit like a placeholder, a little bit like the this keyword. Rather than having to specifically state which object I want to print, I can just have one label called selectTicket, which takes on the particular ticket that I've chosen. So whether that's Amersham, Aylesbury, or High Wycombe, that data is going to be copied into this selectTicket object, of which I can then call the print method of when I come to actually print out that data later. Okay, it's just easier than having to choose either the print method of the Aylesbury or the Amersham or the High Wycombe ticket. All right, saves you having to write that out. Right, so where were we? We were talking about selection. We've done that. We've also printed out that, just a little confirmation to the user that we've selected the Aylesbury tickets. Can I actually do that in the, have I still got this running here? Yeah, I have. So I've seen the selection of destinations available. Let's say that I want to choose the Aylesbury tickets. Let's do that. So I called the selectAylesburyTicket method, and it just gives me a little confirmation to say you have selected the Aylesbury tickets, which is good. But the next thing, of course, once I've selected it in that process, is to actually pay for the ticket. So let's move on to the fourth feature here, which are, we're told explicitly here to add methods to the ticket machine so that the user can insert 10 pence, 20 pence, a pound, or £2 coins. Right, so again, if we go back to the ticket machine class, you might have seen that we've actually been given a insert money method, which in theory would take any amount that you pass to it, as long as it's a positive integer, that is. We can't enter a minus value. We don't want to take money out of it. We can't insert negative money into the machine. So actually, we've got this this conditional statement here to say, you know, want to check that the amount is greater than 0. Want to check it's a positive amount. And providing that it is, we then add that to the balance. That's what this line does here. Remember the assignment operator, the equal sign. It takes whatever's on the right-hand side and then assigns it to the left-hand side. Yeah, so it's reverse order. It reads right to left rather than left to right. This operation is done first. So whatever the balance is at any given time is added to the amount, whatever we enter in, and that's then overwritten in the balance field. Right, so that's how that works. And should we not enter a positive amount, we then get a little output statement to say that we need to enter that. All right, so a little bit of validation there. Okay, but what we want to try and do is to ask the user to enter coins like one used to do pre-pandemic, if you're never back that far, using physical money. We want to try and represent that. And again, there are lots of different ways to do this. There's an extension later which talks about using an enumerations. As you know, if we're going to have a defined number of categories, here we're given 4. We could represent that as an enumeration. That's what they're set up to do. They're set up to work with a defined number of options, which of course makes validation a lot easier. But we'll cover that later. But just for simplicity, again, as we did with selecting tickets, where we just had a method to represent that selection, we could actually create methods to represent the insertion of a particular coin. So you'll see here we've got an insertTwoPound method, which adds 200 explicitly to the balance. We see it's stated here explicitly, adds 200 to the balance, and then update the balance field. And then we've just got a little confirmation to say we've entered £2, and then we're then going to print out the balance to the user, just so they can see the updated balance, like you would usually expect to see, a little confirmation of what the balance has become from that. Okay, so that you could do similar methods for £2, 10 pence, and 20 pence. Have them as separate methods, just to represent that that feature that of using the ticket machine. All right. So let's keep going here. Let's actually show you what that looks like as we've still got this running. So we've selected Aylesbury tickets. Let's insert £2. If I call that insertTwoPound method. Oh, where's the terminal gone? Oh, there it is. Yeah, you just entered £2. Your balance is now 200. Yeah, because we started at 0. So let's try again. Let's because we need £2.20, don't we, to go to Aylesbury. So let's insert £2 again. And then we've got 400 pence, £4. So we should now have enough money to print the Aylesbury ticket, which I think is the next one. Let's have a look at that. Oh, it's not actually written as the 5th one, but that would be the next logical step. Actually, the 5th feature is just saying that we should display the amount entered in the current balance, which, sorry, should have said that earlier. That's what we're doing there. So there we go. We've got the confirmation of what we've entered and the current balance, yeah, which is built into the 4th feature. Okay, so you could do that in those insert methods. All right, but let's. The final thing to do, though, would be to look at how we then print out that ticket to the user. They can actually, put it through the barriers and then go onto the train. So let's come back and have a look at the printTicket method in the ticket machine, right? And remember what I said about the formatting of that printing of the ticket. It worked to have it in one line earlier when we just wanted to display the destinations, but and say you could actually call that print method again should you want to, just to keep things really nice and simple. But again, if you want to customize the formatting that you're given, you'll see here these lines of code which are commented out. You could actually create a nice little output here, which gives some extra information, which kind of represents the formatting of an actual ticket, where you've got things in different places on the ticket. Like you might have the date in the top right hand corner, and then you got the destination on the left, and the cost, etc. You could lay it out just so it looks like a ticket, and to do that you'd probably then have to get the data separately to then inject it into the right place here. So you could do that calling the getter methods, get date, get destination, and get cost by doing that. Or if you want to keep things really simple, you could just call the print method again, just like we did here, where it's displayed on one line. All right, and here we've also got some calculations taking place. And again, this is coming back to what we said about price now. So this is probably where we might have to modify that, rather than using the price field, which is set up in the ticket machine, which we've not actually updated at all, because we're referring to the cost of the ticket object, which is here, rather than the price field of the ticket machine, because that's not been changed in any way. That's probably still going to be 0. So it's best that we modify this now. Rather than saying total equals total plus price, we actually want to get the cost, the price of that ticket, from the ticket object, which we could use selectTicket again to get that. Again, rather than having to write out Amersham or Aylesbury or High Wycombe objects, we can just use the selectTicket. That's what it's for. And then also for the balance as well, just to keep a total of the balance, we can also get the cost there. So basically, wherever you see price in this method would have to be replaced with a call to the getCost method of a particular ticket, right? So you'll see here, this was the old code, what you're given to start with. And this, by the way, is just a check to see that we've got enough money to be able to purchase this ticket, because we want to prevent the user from buying a ticket that they don't have the right amount for. So replace the price with selectTicket.getCost. That's the only thing that we're changing there. So providing you've got a getCost method, what I was saying about the formatting as optional, yes, you could still do that, but you would still need a way to actually get the cost. So if you're going to add one get method, it would be the getCost method. All right, you probably would need that. That would be the one getter that may not be optional. You would need that to actually have some conditionality here and then update all the totals and balances later. All right, so that's what we're doing here. You can see the old code is commented out, and then the getCost just replaces price. Right, so wherever you see price, just replace that with selectTicket.getCost or something equivalent. All right, and then finally, all we then want to do is just print out the updated balance, because obviously we've purchased this ticket, and we want to show what we have now got. So if we've just spent £2.20 or 220 pence, hopefully then that would come down to 180 if we've done our 180 pence, that is, if we've done the calculations correctly. So let's check that. Let's just print out this ticket. If I go back to the BlueJ window, so we did the selection, we've inserted the right amount of money as we saw in the terminal window. So let's now print the ticket. Oh, I need to go back to my terminal. And there we go. We're printing out the destination is Aylesbury, cost 220, and then the date. And then the balance has now been updated to 180. Okay, so that should give you the rough structure for then how to do that for all the remaining tickets, because it's going to be exactly the same process. You would then have to select either the Amersham ticket or the High Wycombe ticket, insert the right amount of money, and then print out that ticket. Okay, so that's hopefully giving you a little template, a little foundation to work with for the other tickets. What you'd have to do from there is create the other ticket objects and the relevant methods for selecting them, as well as additional methods to then insert the other coins, and then you can of course reuse that print ticket method. Okay, and that should achieve the basic functionality of this application. So now that we've got the foundation firmly established, let's briefly talk about the extensions then, just to give you a little head start on those. The first one being raised is constants. However, I'd like to first look at date, and then we can go back to the constant. So if I go to the ticket class, you would have seen earlier, I've actually got some comments written in, just to speed things up here for the purposes of this video. But if you've got the import statement, if you copy that in, that then allows you to use a class, this date class, from a package. The chapter 6 talks about packages in more detail. But this is part of the utilities package in Java, and we can import that specifically to be used with this application. And then what I can then do is change the type of the date field. Rather than it being a string, I can then, of course, create an object of the date class that I've just imported. And because it's an object, I have to instantiate it. So the clever thing here is that if we actually instantiate the date object, so here I'm just commenting out this the string version of date so that I create an object, instantiate the object. And the clever thing, as I was just saying, would be is that this is a really convenient way to get the current date that is being used. So if we're going to do this, though, what we'll have to do is, rather than passing in the string form of the date, because we're not going to do that anymore, we're actually going to set it up here, we'd have to remove it from the parameter list. So I'm just going to delete that from there. And of course, I would then have to go and modify the creation of the ticket objects to remove the string date from there. But just before we do that, there's one last thing I need to do in here, which is, remember, for the getDate method, which returns which did return the string date, I need to modify this so it returns a value of type date, the class date. So rather than a string, it has to be of the date class. All right, but everything else can stay the same. Right, so let's go to TicketMachine and modify that. So I'd say, rather than passing in this third parameter, I want to delete this now and just pass 2. So I pass in those two, the destination and the cost, and they're assigned, and then the date field is then just instantiated and the date assigned at that point. Let's just check that. That's going to run okay. I'm going to have to recompile this. So let's create a new ticket machine. So just as I did before, choose a route. And let's try display destinations. So we go back to yeah, and so so you see here the change. It's got the long form date, a very specific one that is, but it has changed from the string version of date, which we used earlier, to the date class. Right, so that's a simple way to implement the date class and import it. Right, so that's that one. Let's let's go back to tackling the constant now. And as we were in the habit of we just changed the ticket class, the instantiation of the ticket class anyway. So let's go back and modify this. So let's go back to TicketMachine. And the thing about constants is that you can only set the value once at the declaration of that object, or in this, well, it's an object in this case, but it might be a typical, primitive type variable. So I'm actually going to have to move the instantiation of the Aylesbury ticket to the field level. Right, so I've actually got 2 Aylesburys, so let's delete one of them. And all I have to do is to add in the static keyword and then final. Final is Java's equivalent of the const keyword, which you may find in other languages like C#. So that means it's just, at the point of declaration, this is the final value assigned to it. And what's also conventional is to have your constants in uppercase. Right, so just so you can distinguish between typical variables which have changing values and constant variables which only have the one value, we can use uppercase to determine that. So let's just do that. We're going to uppercase, an underscore here, sorry, for that. Right, so with that now done, and of course you'd have to do this for if you have tickets as well, the Amersham and the High Wycombe ticket. But that simple change should then allow you to use the code as you did before. The only difference is that you can't now change those values. They're only declared once, and I couldn't then modify them. So even if I had setter methods within the ticket, I wouldn't be allowed to call those to overwrite the value. Okay. So, here, of course, we need to update these as well. So let's do that. TicketPrint. I can still call the methods, but I just to actually get the data and print the data, I just can't call methods which might overwrite those values. So let's just check. Are there any other instances of AylesburyTicket here? I don't think so, because selectATicket can be the same. Yeah, the selectATicket would have to be dynamic still, because we want to assign something to this later. We can't assign it at compile time because we don't know what the user is going to choose. So we have to keep that one as dynamic, meaning that the value can be set anytime and overwritten at any time. But the standard tickets could be static. So I think that's that. Should we just check that? We have to recompile again. But that's not a problem. TicketMachine. And let's just check that we can indeed display the destination. So let's look at the terminal window here. And yet, as before, it's still the same data. Any difference, as we said before, is we can't then change these values later. Right, so that should be all we need to do for the constants. So the final thing then is to look at enumerations. And helpfully you've been given a lot of the code. So just copy all of this and you want to create a new class. So if you click on new class, obviously give it a name. Best to call it coin in this case to represent the coin entity. But you're going to want to tick this enum radio button here. All right, so I've already done this. Here you'll see the coin enumerate type here. You can see the little word enum there. So let's click on that, have a look there. And I've just copied that in, added a few comments. And helpfully here we actually see 4 custom categories. Because we can't start categories with a number, remember that's the rules of variables. Here they're just referred to as P10. Equally, you could use letters. You could say 10 pence or 10p with letters. But here they're just P10, P20, P100, P200, and they also have integer values as well. So whenever you refer to these, they can be then accessed as integers, which is helpful because that then allows us to increase the value of balance. So if we were to go back into TicketMachine and have a look at one of my other pre-prepared insert methods, you'll see here for the insert 20 pence method, in contrast to what we did before, where we just explicitly stated we want to increase by 200, I could actually pass in a coin and check to see if it has the value, the numerical value of 20, and if it does, then I can increase the balance and print the balance in the same way. Or what you could do, if you wanted to, you could build a insert coin method of which you have multiple if statements inside them, and depending on the value of that coin, it would increase the numerical value by that. Okay, so there's different ways of doing this. Sticking with the formats that we suggested earlier of having separate methods, I'm going down this route, but just adding a little bit of validation there, just to check that it is indeed the 20 pence coin that's going to be passed to this. So how do we do this then? Let's have a look, because a lot of this is going to happen at compile time. So what's going to happen is when I click on the insert 20 pence, you'll see there in the signature that it's got a parameter of the coin enumerate type. So it's there that I need to specify which coin I want to pass in. And the way that you do that is you have to first refer to the type, which is coin. That's the name of my coin enumeration. And then I have to specify which category. And in this case, let's say P20, so it's coin.P20. P20 is a category of the coin enumeration. So let's pass that in, and that checks out okay. you see that we've increased the balance by 20. All right, so that hopefully, if you do a similar process for the other insert coin methods, hopefully that would allow you to then limit the choice to those 4 coins specified here: 10p, 20p, £1 and £2. All right, so I hope that's helpful. I hope that gives you a little bit of a start then on how you might go about applying these extensions. Give it a go, see how you get on, and we'll take it from there.